This platform is not yet available, but I know the guys are working on this. And the idea is to take the low-cost board, what we call mirrored RF, and connect it up to Xilinx boards through the kind of things that E-Elements is designing. And again, it would be a very low-cost solution directly connected to those type of platforms. So again, if you're a Xilinx user, you would be able to make use of this platform and have your system developed for any standard you wish. So all of what I've just discussed is based on development platforms. You know, things that people do in order to make new type of hardware circuits. But really, there are quite a lot of examples using our device that are actual products that are being deployed out there. Typically, they consist of FPGAs and DSPs. I do see a lot of DSP solutions from Texas Instruments, for example, used alongside FPGAs, together with our transceiver, together with front-end modules, consisting of power amplifiers and filters. In fact, we have a good potential partner that we will be working with who are making these filters called Timwell. And together, we would be able to come up with highly flexible solutions that can address essentially any application, as I keep mentioning. So to highlight this, let's look at some real products that are actually in the field out there. Everybody is talking about WCDMA, 3G, and 4G, but there is a huge GSM market out there. This particular design is a GSM base station that is being deployed in developing countries, some parts of India, in some islands around the world, where you can have a small base station and very cheap phones and providing communication to the masses. So with a sub $10 GSM phone and these type of base stations, which are based on FPGAs and our transceiver, you are actually giving wireless communication to people who do not have access to such technology today. The same platform could be made to cater for multiple standards. In this case, we have a design which covers GSM and WCDMA. So 2G and 3G technology all combined into one, just because our transceiver is capable of doing that. Obviously, digital portion, FPGAs, and baseband are already capable of doing multi-standard. In digital domain, it's very easy. So another set of products. All of these uses our transceiver. It goes from residential femtocell using our device together with some baseband solutions, in this case Broadcom, all the way to an enterprise CDMA solution for some 120 users. So going from 4 users to 120 users using the same RFIC, the same transceiver, all across the board. So with that in mind, you could already see that there are quite a lot of commercial deployments of what we have actually produced. Everybody talks about LTE. Our customers have been developing LTE base stations and repeaters, for that matter, for almost 2 years. So they were well ahead of the game because they had access to a transceiver which could do these standards. So another aspect of having a flexible solution, having a transceiver of this kind, means that you can develop your products well ahead of everyone else. You don't have to wait for a transceiver to be designed, manufactured, and come into the market. You already have access to it, and you can jump into developing your product. So these particular customers of ours have got a huge head start over everyone else. So although LTE market for residential femto should happen in 2014, these guys are already talking to the operators and presenting their designs to them. These are some examples of repeaters, which again uses our transceiver together with FPGAs. Repeaters are very important in the cellular infrastructure. The reason, for example, there is no coverage issue in Korea or Japan is because of these stuff. Wherever there is a coverage problem, they have a repeater, and as a result, they are able to provide a very good coverage in these countries. So again, these platforms up to now were based on discrete solutions because they could not find an integrated transceiver to go across all these frequencies that they wanted to do. So in combination with our transceiver and FPGAs, they managed to come up with very low cost, highly efficient, highly programmable devices out there. So these are essentially commercial deployments of our chip. What is important is what will happen for the next generation of products. So already there are a lot of users or potential customers that are deploying our transceivers for the next generation products that will come into the market. I'll just give you a couple of examples. I know the time is very short, but this particular one is implemented by a company called Epic Solutions in the US. It uses Lime transceiver, FPGA, and Texas Instruments DSP. And essentially the philosophy is as follows. As far as the next generation of wireless technology is concerned, you should not have to change your hardware if you change the standard or the frequency. Much in the same way as on your laptop, when you want to switch between PowerPoint and Word, you don't change your laptop. It's the same laptop. All you do is you change your software. So they've come up with a platform that could be turned into a test and measurement equipment. It could be turned into a base station, or in fact, any communication system you wanted it to be, because it's highly programmable. It's just all about software change. So the next generation of equipment for this type of applications will be just like your laptop. Common platform, common design, but software change will give you different applications. And in fact, all of these products are based on the same notion. So we fully expect in the next 2 or 3 years to see a lot of such platforms getting generated whereby you don't change your hardware. So as a result, if, for example, femto does 2 million a year, another application, maybe machine to machine, does another 2 million, since it's the same hardware, you would be able to cost reduce very much because you've doubled your market. You doubled the number of units that are going to be shipped out there. So in conclusion, we see combination of flexible transceiver ICs and FPGAs and DSPs the way forward. There is no point designing dedicated solution when you can have flexibility. What we are doing by linkage to FPGAs, by supplying our design of our boards as open source, widely available out there, we are accelerating the adoption of some such solutions. As I mentioned, in short 2 years that our product has been in production, we've signed up 130 customers. We are going to increase that to about 1,000 by this time next year. And through the open source, there will be a large community of people designing our part into their products, and hence it will be very well supported through the community. It is the combination of these aspects which I believe will see a wide adoption of such technology going forward. Thank you very much.
Thank you, Abraham.